Here I am going to discuss about the binomial distribution and the maximum likelihood estimator of the binomial distribution. So at first I will try to write the general form of the binomial distribution. Now what is the general form of binomial distribution? It tells us that function of xi, binomial distribution is basically can be written in a general form that function of xi equals to mxi. This is nothing but a combination mcxi. Some people can also write it as mcxi, probability to the power xi, and q, that is nothing but 1 minus p assigned with a power of m minus xi. This is the general form of binomial distribution mxi, p to the power xi, q to the power m minus xi. Now this is a function of p, because q is nothing but 1 minus p. So this entire in this entire function or in this entire form, the only parameter that can be estimated is p. So we have to estimate the value of p, and now we have to estimate the maximum likelihood estimator of p. For going into that, I have to write this function as a function of p. I have to write this entire general equation as a function of p, and this can be further written as summation pi I equals to 1 to n, because we are going to write it in the product form, and the product form is always represented by the help of pi and fi of xi. Now this can be further written as pi, and in place of fi of xi I may write this mxi, p to the power xi, q to the power m minus xi. Okay, so I am writing it as mxi within bracket p to the power xi, and in place of q I am writing 1 minus p to the power m minus xi. Okay, now if I have to put this product form within all the terms of the equation, or all the term of the functions, if I have to put this product or put this pi or put this product form, then it can be written as this p to the power xi. This xi will have the summation with it whenever we are trying to put a product form in it. Then this xi will have a summation form. This m will have n multiplied with it, and this xi will have summation with it. But this p and 1 minus p won't change, because it is nothing but the parameters, and parameters will not be changed whenever we are taking the product form with all the forms of the, or with all the parts of the equation. So basically it will now become as pi m of xi, it is nothing but the combination p to the power summation xi and 1 minus p to the power m minus xi. Now this m will become m into n, or n into m, and this some xi will become summation xi. Okay, so now this is the general form of our function L of p. Now if we do the logarithmic transformation of this function, then the logarithmic transformation of this function will give us a result that will actually give us that this p to the power summation x. At first we will try to convert this. So p to the power summation x, if we do the logarithmic transformation of it, it will become summation x into log p, and this part 1 minus p to the power nm minus summation xi. If we do the logarithmic transformation to it, it will become plus n into m minus summation xi, from power it will become base, into log 1 minus p. And this part, it won't be it is not required to be changed, or it will be as it is even after the logarithmic transformation, because it is representing a combination. So it will be pi m xi. Okay, now we have to do the differentiation with respect to p only, because p is the only parameter, and we are supposed to do the we are supposed to do the differentiation with respect to the parameter present in the equation. We are supposed to do the differentiation with respect to the parameter present only. So we have to do the differentiation of this log LP with respect to the P. So it is nothing but del log LP with respect to P, it will become as so this part, when we do the differentiation, this part will be summation xi into 1 by P, because if we do the derivative of log P with respect to P, it will be nothing but 1 minus P. This part will be treated as constant, and log 1 minus P will become 1 by 1 minus P, and then we have to do the differentiation of 1 minus P, this minus P again. Then we have to do the differentiation of minus P again, so that will be minus 1. So now if I write this, then it will become 1 by P into summation xi, and further it can be written, this part will be treated as constant, nm minus summation xi, this part will be treated as constant. Okay, so nm minus summation xi can be written plus nm minus summation xi, and this log 1 minus P, at first we will do the differentiation of 1 minus P only, so it will be 1 by 1 minus P, so it will be nothing but plus 1 by 1 minus P. But then we have to differentiate this 1 minus P, this inner term also, and in this inner term 1 will be differentiated and will get a result of 0, but this minus P will be differentiated with respect to P, so it will give us a result of minus 1, so we have to multiply it with minus 1. Then this product, this entire term, if we do the differentiation of this entire term, it will be nothing but 0, because this term doesn't have P in it, and if we do the differentiation of this entire term with respect to P, then we will be getting a value of 0. Okay, this entire term is nothing but a constant. So now this is our equation. We are taking this first order condition as equals to 0. We have the main target of ours was to maximize this log L of P. Our main target was to maximize this, and for maximization two conditions must be satisfied. One is the first order condition, that is equals to 0, and another one is the second order condition, that is less than 0. So we have to find out the first order condition and the second order condition. We have found out the first order condition here. This is the value of first order condition. We have to take it as equals to 0, and from this we will be able to find out the value of P from the equation, and then we will do the derivative of this first order condition again and see whether we are getting the value of second order condition as a negative value or not. If we are not finding a negative value, we cannot say that the function is maximized and the value of P that we have obtained is proper and correct. If the second order condition is showing us a negative value, then we can easily say that the value of our second order condition is negative and our function is maximized and we are getting a proper P value. Now the second order condition is supposed to be derived, but we are going to do it after the completion of the solution of P value. At first I will take the first order condition equal to 0 and find out the value of P. Then I will go to the second order condition and check whether there is negative value coming out or not. So for finding out the value of P from this equation, I will take this entire thing on the maybe I have it's okay. At first I will let me write it in a new page. So the equation that we have obtained here is 1 by P summation xi plus 1 by 1 minus P multiplied with mn minus summation xi equals to 0. Sorry, we have another minus 1 here also. So let me write that minus 1 equals to 0. Now if I multiply this minus 1, it becomes nothing but 1 by P summation xi minus 1 by 1 minus P mn minus summation xi equals to 0. Now if I put this entire term 1 by 1 minus P into my mn minus summation xi on the right hand side, now this entire term now becomes 1 by P summation xi equals to 1 by 1 minus P mn minus summation xi. Now if I try to solve this, for solving this I am just doing nothing. I am actually taking this 1 minus P on the left hand side, and I am taking the summation xi on the right hand side. So it will now become 1 minus p by p equals to as you can see, where we have mn minus summation xi divided by mn minus summation xi divided by xi, summation xi. So this is what we have here, and if I just write it as 1 by p and mn by summation xi equals to minus summation xi by summation xi. I think I can write it in this way. It is very easy to understand. This will be cut, and we will get the value of mn by summation xi minus 1, okay, and 1 minus p by p. Now take this minus 1 on the left hand side. It will become 1 minus p by p plus 1 equals to mn by summation xi. So if we solve it, it will be p 1 minus p plus p, and we have mn sorry, it is not summation, mn by summation xi on the right hand side. Now p and p will be opted out. We will have only 1 by p equals to mn by summation xi. Just cross multiply, we will get the value of p equals to summation xi by mn. Now this is actually nothing but summation xi by n. This term, this part is nothing but x bar. So I may write the p value equals to x bar by m. So x bar by m is our estimator, maximum likelihood estimator from the binomial distribution. Now if I want to put this binomial distribution into in the second order condition, if I want to check the second order condition whether it's a negative value or not, then for that I may just give the binomial distribution into a second order derivative. The first order derivative was this, right? So if I actually take this first order derivative and do the second order derivative, I am trying to do this here because then it will be easier to understand. Then I am just writing del square log L of p by del p square. So now what will be the value of the second order condition? Now if I am not going to derive it entirely, I am just going to write the value. This part, if we you may check it after doing the derivative, this part is going to give us the value of minus 1 by p square. How? I am just going to give a little hint. 1 by p is nothing but p to the power minus 1. If you do the derivative, it will be minus 1 into p to the power minus 1 minus 1. If we do the derivative with respect to p, then this is the thing that we obtain. So it will be nothing but minus 1 by p to the power minus 2. So it will be minus 1 into 1 by p square. Okay, so that's how I am finding minus 1 by p square here. And this part will not have any derivative. If we do the derivative with respect to p, this part will have a derivative, and this part will have a derivative of 1 by 1 minus p square. How? You may found it. I mean, you may do it. It is very easy. I am not going to elaborate it here. I have already twice elaborated it. And I feel there is a mistake probably. Yes, I think this is the mistake that I have committed here. It was not supposed to be plus here. In the next slide, that mistake was not present. As you can see, it was no plus present. But here I have done that mistake. But it is sorted out now. Now if we do the derivative, this part will be treated as constant obviously. So it will be kept here. I told it wrong that it will be taken as constant. No, it will be taken out as constant, but it will be kept. Mn minus xi summation xi it will be there, and 1 by 1 minus p square will be there. Okay, and this minus term will be also opted out if you have to do the complete derivative for that. And after doing that, if I write this form of the second order condition, second order derivative, then that will be del square log L of P is divided by del P square. What will be the value? The value is showing us that minus 1 by P square into summation xi minus 1 by 1 minus P square into nm minus summation xi. Okay, now if I take the minus common out of it, it will be 1 by P square summation xi plus 1 by 1 minus P square nm minus summation xi. This part is positive, this part is positive, this part P square is positive, P square is also less than 1, so this part is positive, this part is positive, it is also square, this part is positive. Entire part within the bracket is positive, but it is assigned with a negative sign. That means the entire term has become less than 0 or negative. So the second order condition is giving us the proper solution, that we are actually getting the maximization of the function, and we are also getting the value of P, that is maximum likelihood estimator of the P, as x bar by m. As you can see it from the first order condition equals to 0, that this is the value of maximum likelihood estimator of the binomial distribution, which is x bar by m.